Hello, dear young minds. Welcome back to PhysicsPoint. Here is the second lecture of the chapter Force and Laws of Motion. All right, already the first lecture is uploaded. You can go back to the playlist and watch that video, then come to this video so that you understand it in a better way. All right, in this second video, we'll be talking about Newton's first law of motion. Already we talked about inertia and all in the first video. So Newton's first law of motion is based upon that only. All right, so we'll talk about this. Then we'll talk about something called momentum. All right, the symbol of momentum is a P. All right, it's a vector quantity. We give something like this. And Newton's second law of motion, we'll discuss about this. And we'll discuss some of the numericals on second law of motion. All right, without wasting any of our time, let's get started. My name is Shrikant Bashetti, and I run this physics channel called PhysicsPoint. This is your beautiful physics channel, PhysicsPoint. Let's get started. All right. So, what is this Newton's first law of motion? Okay, everybody put the heading Newton's first law of motion. All right, Newton's first law of motion. It's quite simple. Newton's first law of motion says a body do not change. A body do not change its state of motion. A body do not change its state of motion till we apply external force. Till we apply external force. All right, different books have different definition, but all will come back to the same thing. A body do not change its state of motion. State of motion means the body can be at rest, the body can be there in uniform motion. You know about that. A body do not change its state of motion till we apply external force. All right, so to elaborate it, if you want to elaborate this definition, how you are going to write? You are going to write it as a body at rest. A body at rest remains at rest. A body at rest remains at rest, and body in uniform motion remains in uniform motion only until and unless we apply external force. This is complete Newton's first law of motion. Both of these are same. A body at rest remain at rest, and body in uniform motion remains in uniform motion only means what? A body do not change its state of motion. If it is at rest means it will remain at rest only, and if it is in uniform motion it will remain at uniform motion only until and unless we apply external force, or till we apply external force. Both are same things. Okay, it is nothing but inertia. No, a body at rest will remain at rest, and body in uniform motion will remain at uniform motion means this is inertia. So that's why this Newton's first law of motion is there. No, Newton's first law of motion is also known as law of inertia. Okay, if it is in the if it is asked in the exam what is law of inertia, you should be able to write any one statement, this one or this one. No need to write both the things. All right, so already for this inertia I have given so many examples. All right, so many examples in the first video. All right, so just go back to the first video and watch it so that you understand more about this inertia and its examples. All right, so Newton's first law of motion is quite clear. It's quite simple. Already I give you the definition. All right, so we have to move to Newton's second law of motion now. So before getting into Newton's second law of motion, let us see one definition, one term here, that is called as momentum. All right, what is this momentum? The symbol of momentum is P. Actually it is a vector quantity, that's why we give this vector symbol. But right now for 9th standard there is no need of this concept of arrow mark or vector, something like that. Momentum means, for example, there is a body. Okay, there is a body here. All right, there is a body and it is having mass m. All right, and it is moving with velocity v. So product of this mass and velocity, product of mass and velocity of a body, product of mass and velocity of a body is called its momentum. All right, its momentum. So if you want to write it, it's like P is equal to m into v, mv we can write. All right. So what is the unit of this P, or what is the unit of this momentum? The unit of momentum is m means what? Kg, and v means velocity, that is meter per second. So the total unit becomes a kg meter per second, or you can just write it as kg meter second to the power minus 1, means it is kg meter per second. Now you will need to understand what is the actual meaning of this momentum. All right. So what does this mean? For example, there is a truck. Okay, there is a truck. What will be mass of this truck? Let us take this as 1000 kg. Okay, approximately I'm taking. And here there is a cycle. Okay, here there is a cycle, and mass of this cycle is, let us take this as 50 kg. All right. Now there is a not a person, there is some object here, or it is moving with some velocity. This truck is moving with velocity 2 meter per second. All right. This cycle is also moving with velocity 2 meter per second. Here also the velocity is 2 meter per second. All right. So here are two cases what I have explained. Now what is the moment of this truck here? So it is mass into velocity. Mass into velocity, same definition. Mass is 1000 and velocity is 2. So how much it becomes? It becomes 2000 kg meter per second. This is a momentum. Look at this. Now what is the momentum here? So here is also the formula is mv. What is m? 50 into what is v? 2. So how much it is? 100 kg meter per second. So this is the momentum here. Now look at this, both are moving with the same velocity, that is 2 meter per second. Here also it is moving with 2 meter per second. But momentum is different because of what? Because of these masses. Here mass is 1000 kg, here mass is 50 kg, but they are moving with same velocity, no? So even though they are moving with same velocity, because of mass, momentum is different. Momentum means what? It is the effect. How much effect is caused? How much effect is caused? That's what is what? That's what is momentum. Okay. Now look at this. 2 meter per second means it's very moving very slowly. A truck passes on a person very slowly. For example, there is a person here. He is lying on the road. All right, he is lying on the road, this person, and this truck goes very slowly on this person, means what will happen to this person? This person will die or not? Definitely he will die. All right. Now here the person is lying on the ground, and this cycle also goes very slowly with the velocity 2 meter per second on this person. Will this person die? Maybe he will not have much injuries, because this cycle effect is very low, right? Even though they are moving with the same velocity, they are going to cause different effects according to their masses. Look at this. According to their masses, they will cause different effects. Even though truck is moving very slowly, it will cause the death, and here there will be no injury. I hope you are understanding what I'm trying to say. All right. So basically momentum means how much effect is caused. All right. And this effect is caused due to combination of mass and velocity. Both mass and velocity are very important. Now look at this bullet. No, if you take the example of bullet is having less mass, no? Less mass it is having, but it is having very heavy velocity, very high velocity. So together it will create such a momentum that it will cause a harm to us once the bullet is fired at us. Look at this. It is not that if mass is less means the effect is going to be very less. No, if cycle comes and hits you with very heavy speed. All right. So are you understanding my point? So basically, as a combination of due to combination of mass and velocity, due to this, what will happen? Effect is caused. Some effect is caused. That effect itself is known as a momentum, and that momentum formula is P is equal to mv. Look at this. This is a cycle. It keeps on going like this. All right. I hope the concept of momentum is quite clear. All right. Now let us look at Newton's second law of motion. All right. So what is this Newton's second law of motion? So very important law. All right. So somebody says Newton's second law of motion means F equal to ma. They say the formula, but that is not the the formula is there, but definition, Newton's second law of motion, what it says? Newton's second law of motion says rate of change of momentum. What is this? Rate of change of momentum. I will explain this. Okay, first of all, write down this. Rate of change of momentum of a body. Rate of change of momentum of a body is directly proportional. Is directly proportional to the is directly proportional to the force applied on the body. Force applied on the body. Look at this. All right. So let us try to represent it in the form of equation. Rate of change of momentum. What do you mean by rate of change of momentum? Rate of change of momentum. All right. Rate of change of momentum is directly proportional to applied force. It is directly proportional to applied force on the body, or force applied. All right, so this is what is being said by Newton's second law of motion, and let us try to break it down. So what do rate of change of momentum, what does it mean? What is the meaning of this? Now let us try to take a body here. All right, so here is a body. Otherwise, before taking the body, one more thing, let us write here. Rate of change of momentum means what? Rate of change of velocity means, do you understand? Rate of change of velocity means we wrote it as v minus u divided by t, no? Final velocity minus initial velocity divided by time. This is rate of change of velocity. So similarly, rate of change of momentum means final momentum, correct, no? Final momentum minus initial momentum. Otherwise, you can just write it as a change in momentum. Rate of change of momentum means change in momentum. Correct? Change in momentum divided by time taken. Change in momentum divided by time taken means what? Look at this. Change in momentum divided by time taken means it is rate of change of momentum. So change of momentum divided by time taken means rate of change of momentum. And this is directly proportional to force. Applied force means force symbol is F. All right, so how to go about this change in momentum, we'll see that diagrammatically. All right, here is a body. Okay, so the mass of this body is m. It is moving with some velocity u. All right, now it was moving with velocity u. Now what happened? Now on this body, whatever this body is there, no, with mass m, whatever it is there, it was moving with velocity u. Now you applied some force. You applied some force for some time t. Okay, up to time t you have applied. It was moving with velocity u only. All right, so afterwards you started to apply some force. Look at this force. You have applied some force on it. Now what will happen if you apply this force for time t? You will find that this body, whatever this body is there, no, so this 1 second, this body is there, no, so this body will be having same mass m, but it will start to move with velocity v. Look at this. Now what is the initial momentum here? Initial momentum means we write it as pi. Pi means initial momentum. All right, so what is this initial momentum? Mu. So this is the initial momentum. All right, now here look at this. Here it got final velocity, so that's why we write it as pf. Pf means final momentum, so that becomes a mv. Okay, for your reference, let me write here. Pi means what? Pi means, I means initial, p means momentum, so initial momentum. And pf means what? Pf means a final momentum. All right, final momentum. Okay, now look at that formula. What is that formula? Change in momentum. Change in momentum means what? Change in momentum means final momentum minus initial momentum divided by time taken. Correct, no? So final momentum. So change in momentum means final momentum minus initial momentum only. So that is Pf minus Pi divided by T, and that is directly proportional to F. Let me write it reverse form. Okay, so I'll write it as F is proportional to Pf minus Pi divided by T. Why I am writing F? Because after applying force only all these things are happening. That's why I'm writing force before. Okay. Now what will happen? So it will become like F is proportional to Pf means it is mv. Already we have calculated here. Look at this. Pf means mv minus Pi means mu, then divided by T. Then it becomes F is proportional to m bracket v minus u divided by T. All right, so then it becomes F is proportional to m into how about this v minus u divided by t? Don't you think it is a rate of change of velocity? Rate of change of velocity means it is acceleration. All right. To remove this proportionality sign, we give one constant called k. K into ma it becomes. But in SI system, SI system means International System of Units. In SI system, K is equal to 1. Why this K is becoming 1? Because this force is there, no? This force depends upon this mass and acceleration only. It do not depend upon any other thing. Alright, so that's why F is equal to ma. So this is the famous formula of Newton's second law of motion. But whenever somebody is asking what is Newton's second law of motion, directly you should not be telling this equation. You have to say this definition. What is that? Rate of change of momentum of a body. Rate of change of momentum of a body is directly proportional to force applied on the body. Then rate of change of momentum means change in momentum divided by time taken is proportional to force you have taken. All right. Then after that change in momentum, you have to take initial momentum and final momentum. Then you have to look for final momentum minus initial momentum divided by time taken is proportional to force. Then reverse it. Then all other derivation carried forward, and F is equal to ma. So that means if there is a body of mass m, okay, and if you are moving with some force F, okay, definitely it will start to move with acceleration a, then you can apply the formula F is equal to ma. All right, so we have so many numericals here, so many numericals, which are recorded here, so I will solve them. Before that, you need to understand, if there is a body of mass m and force F is applied on it, and it is moving with acceleration a, means the relation is F is equal to ma. It will hold good. All right, so this is the relation which we'll be using extensively in the numericals of second law of motion. All right, so let's get into the numerical section and solve some of them. All right, here is the first question. An object of mass 25 kg, mass of the body is given. So here is the mass. Mass is equal to how much is that? 25 kg. All right, gains a velocity of 10 meter per second in 2 seconds. It is getting a velocity of 10 meter per second in 2 seconds, means time is 2 seconds. Starting from the rest means initial velocity is 0, and it is getting a velocity of 10 meter per second, means final velocity is 10 meter per second, and it is taking 2 seconds, means time is equal to 2 seconds. All right, now they are asking us to find force experienced by the body. All right, so whenever they are asking force, means immediately you should be able to apply the formula. So what is that formula? That is force is equal to mass into acceleration. All right, now you must be thinking, I have mass, how about acceleration? You have v, u and t, so you can write it as m. Then a means what? A means you can write it as v minus u divided by t. You can write it, no? Otherwise you can find it out separately also, there is no issue. M means 25 kg, then bracket v means 10 minus u means 0, then divided by t. T is 2. All right, so it becomes 25 into 10, it becomes 250. 250 divided by 2, 2 ones are 2 ones are 2 twos are 1 is a carry, 2 fives are, so force is like 125 Newton. So a 125 Newton of force has to be applied on this body, so that the body from the rest gains a velocity of 10 meter per second in 2 seconds. All right, fine. Then moving forward, let's go on to the next question. The question goes like this: in how much time? In how much time means they're asking about what? They're asking about t. T is equal to question mark. All right, in how much time an object of mass 100 kg? So mass is what? Mass is 100 kg. In how much time an object of mass 100 kg will speed up from 10 meter per second to 30 meter per second if a force of 100 Newton is applied on the body. Will speed up from 10 meter per second to 30 meter per second means initial velocity is 10 meter per second. Final velocity is 30 meter per second. All right. If a force of 100 Newton is applied, that means force is equal to how much is that? Force is 100 Newton. All right, now they are asking about how much time and all. Now look at this. You have mass, and you need to find out the acceleration. Acceleration as in v minus u by t is not known, and we can easily find it out. Okay, all right, so let us apply that. So what is that formula? F is equal to mass into acceleration. and same thing becomes F is equal to m into acceleration means v minus u divided by t. All right, let us substitute the value. So what is the value of F? F is 100 Newton, and that is equal to m is 100 kg. All right, and bracket V. What is V? V is 30 and U is 10, and divided by time we want. Now this 100 they get cancelled, and let us bring this t this side. So t is equal to 30 minus 10 is 20 seconds. I mean, therefore the body will take 20 seconds to speed up from 10 meter per second to 30 meter per second whenever we are applying a 100 Newton force. What does it mean? It means there is a body of 100 kg. It was already moving with velocity of 10 meter per second. All right. Now on this body, if you apply a force of 100 Newton for how many seconds? For 20 seconds, like this. For 20 seconds, if you keep on applying this force, I mean the velocity will be 100 kg will remain as usual. So but the velocity becomes 30 meter per second. All right. So this is the meaning of this. Moving on to the next question, let us have a look at this third question. A truck of mass 1500 kg. All right. So mass of the truck is given. Mass of the truck is 1500 kg. All right, is moving with speed at 20 meter per second. All right, so it is moving with speed 20 meter per second. All right, no problem. If a force of 1000 Newton is applied for 10 seconds, I mean force is given and time is given, find velocity of the truck after 10 seconds. All right, so here it is saying the truck of mass 1500 kg, it is recorded, is moving with speed 20 meter per second. That means initial velocity is 20 meter per second, that is there. Then afterwards, if a force of 1000 Newton is applied, so force is how much is that? 1000 Newton. All right, 1000 Newton is applied for 10 seconds. So time is equal to 10 seconds. Find velocity of the truck after 10 seconds. So time is 10 seconds. They are asking about velocity, means they must be asking about final velocity. All right, so let us find out. So by using all these details, let us find out that so what is the formula for force? Force is equal to mass into acceleration. Again, mass into acceleration is v minus u divided by t. So here is the force. Let us substitute all the values. So what is the value of force? Force is 1000 Newton. 1000 is equal to, what is the value of mass? Mass is 1500 kg. Bracket v is not known, minus u is 20. All right, then divided by t is 10 seconds. Okay, so here what will happen? Look at this. This 0, this 0, they'll cut off. This 0, this 0, they'll cut off. All right, so let me keep 100 here only, 100, and let me bring this 15. It becomes divided by 15, and that is equal to v minus 20. All right, so now I mean, how to do this calculation? You can easily do it, no? So it is like 5 3s are and 5 20s are. All right, so it becomes 20 by 3 is equal to v minus 20. All right, let us keep v there only and bring that minus 20 this side. 20 by 3 plus 20. So 3 ones are 3 6 are 18. 2 is the carry, again 6 are. So it is like v is equal to 6.6 plus 20. So final velocity of this truck will be 26.6 meter per second. All right, so all these problems are based upon this formula only. F is equal to ma. All right, whatever numericals will be based upon this Newton's second law of motion, we have to use this F equal to ma again and again. Okay, in all these numericals whatever I have solved, I have used that to find out different things. Okay, fine then. So I hope you got I mean a lot of things from this video. And let me before ending this video, let me define one more thing. Let us define one more thing. So that is like define 1 Newton. Definition of 1 Newton. Definition of 1 Newton. Define 1 Newton, they will ask you. Okay, so let me remove this. Definition of 1 Newton. Now what is the formula for force? Force is equal to mass into acceleration. For example, if there is a body of mass 1 kg and it is moving with acceleration of 1 meter per second square. Look at this. There is a body of mass 1 kg here. All right, so 1 kg body is there. It is having mass of 1 kg and you have applied some force on it. you have applied some force on it, and afterwards you found that this body is moving with an acceleration of 1 meter per second square. Now how much force you must have applied? Just look at this. I mean, mass is 1 kg into acceleration is 1, so you will find out that force is going to be 1 newton. Okay, so that's why I mean 1 newton, how to define it? The definition of 1 newton goes like this. I mean, uh, when some force, when some force is applied, when some force is applied on a body, applied on a body of mass 1 kg, 1 kg, and it starts to, and it starts to move with, and it starts to move with acceleration, and it starts to move with acceleration 1 meter per second square, then that force, and then that applied force, then that applied force is said to be, is said to be 1 newton. Look at this definition carefully. It has become little lengthy, but it is elaborate. When some force is applied on a body of mass 1 kg and it starts to move with acceleration 1 meter with acceleration 1 meter per second square, then that applied force, whatever force we have applied, no, that is said to be 1 newton. All right, if a body of mass 1 kg starts to move with an acceleration of 1 meter per second square, when we apply some force, then that force is said to be 1 newton. All right, so actually newton means what? So look at this. F is equal to ma is there, no? So F is equal to ma formula is there. So m means what? Kg, and acceleration is meter per second square. So force means newton. So actually newton means what? The newton is equivalent to kg meter per second square. All right, so mass into acceleration. So kg comes from mass and meter per second square comes from acceleration. So that's why what I'm telling here is newton is equivalent to whatever this newton is there. So this is equivalent to kg meter per second square. All right, so this was one information which was missing, that also I gave you. All right, so definitely these videos are very useful for you and you must be getting benefited from them. It is your support which keeps us going. So please make it sure that you are liking the video and share this video with your friends, and don't forget to subscribe to the channel, because it is your subscription which gives us a lot of motivation to make all these videos. So me, Shrikant Bashetti, I am signing off right now from PhysicsPoint, and I will come back again onto this PhysicsPoint, your beautiful physics channel, to teach you much more things. Thank you very much. Have a good day and bye bye.